Welcome to Math 1300. This is Nunez Community College. Today we will be dealing with section 2.1, which is functions and function notation. I guess to start out with, let's look at a relation. A relation is defined as a set of ordered pairs. Set of ordered pairs in braces could be like 1, 2, 3, 4, 7, 9. Again, all we have is 3 or more. We could have 100. It does not matter, but it's sets of ordered pairs. These sets of ordered pairs are broken down into two parts. One part is called a domain. And the domain is the x values. The x values would be in ascending order, so it would be 1, 3, and 7, okay? And we also have the y values, which is called the range. It's the y values. And the y values here would be what? 2, 4, and 9. If in fact any of the values repeats, we would only put it once. So if we had another one with 3, 10, we would only put the 3 one time. This is known as a relation where we have domains and ranges. Now, we have relations that become special. These special relations are called functions. A function is a special relation where the x value never repeats. So it's a relation where the x value never repeats. An example of a function, 1, 4, 2, 8, and 9, 14. And just like a relation, the function has a domain and a range. This function's domain would be 1, 2, and 9. And the range would be 4, 8, and 14. So this would be a function if, in fact, we had another set that maybe would be 9, 18. Now it would not be considered a function because the x values would repeat. So the only way it's a function is that the x values do not repeat. Again, through each we have domains and ranges, which is the x values and the y values. Another way of looking at them is to look at them as equations. Suppose I have x plus y equals 7, y equals x squared plus y squared equals 14, and y equals x cubed plus 8. How do we tell whether or not an equation is a function or not? Well, this one is a function. Well, we put yes instead of is. Yes, this is a function. This is a linear function. The second one, yes, it is. It's a quadratic function. Linear function, an example, might look like this. It's a line. Quadratic function looks like this. It's a parabola. This one here is not a function. This one is a circle. And here, this one is a function. This one is a cubed function. So how do we tell if it's an equation form? We look for the y values. We look for the y values. And the y cannot be to an even power. The y cannot be to an even power. in 90% of the problems that it's not going to be a function, we're basically looking to make sure that y is not squared, because that's the way we list it most of the time, if y is squared. So if y is to an even power, if y is to an even power, then we don't have a function. If y is to an even power, we don't have a function. Other than that, y squared, y to the fourth, y to the sixth, other than that, the only other way we'd have it might be something like this. Y equals the square root of x. Because since this is the square root of x, if we squared it, we'd have to square the other side, and this would lead me to y squared equals x, because squared undoes a square root. Hence, leaving me with y to an even power. Okay? So this is the only kind of exception, if you will, not to have y actually squared or to an even power, is if we have this, because we'd have to square it to get x, again, leaving me with y squared. So that is how we find if an equation could be a function. Suppose we look at the graphs. I said that was linear, that was. I said that this was quadratic, that was. I said that this was a circle, that wasn't. And then the last one, which was cubed, looked like this. Why is it that this one is not? It's not because if we look at it, wherever we have an x value here, if I drop it down, that's the same x value. This may be, for instance, -3, 3, and down here would be -3, -3. The x values would repeat. So what we've developed for this is we developed something called the vertical line test. If we can draw vertical lines through the equation to the graph and not hit the graph more than once, then it is a function. Again, we'll only hit it once, we'll only hit it once. But if we can hit it more than once, it is not a function. It's called the vertical line test. Okay, we have the examples that we're looking for. Now we want to look at function notation. Function notation. This is an equation if we have an x-axis and a y-axis. And I draw a line. This line might be y equals 2x plus 1. That's an equation. If I do the exact same thing, x-axis and function axis, instead of y-axis, I'm going to call this the f parentheses x axis, otherwise known as f of x. This function has the same exact meaning, but it says f of x equals 2x plus 1. This is the function, f of x is equal to 2x plus 1. This is the equation, y equals 2x plus 1. All we're doing for functions is changing the y-axis to the f of x axis and calling it a function. So, when we look at these functions, I want to find out the domain. The domain. Well, if it's in ordered pair form, I just look at the ordered pairs and pick out all the x's. But if it's in some form where we have arrows, arrows means going on forever. So it means everything from -infinity to positive infinity. Well, suppose instead of it being graphed for us, suppose we have it in the equation form. F of x is equal to 2x minus 5. Well, this was the equation of a line, linear. This is also equation of a line. So in this case, the domain is everything, negative infinity to positive infinity. And the domain is always everything, negative infinity to positive infinity, unless you get one of the two following with restrictions. One restriction is going to be a radical. F of x is equal to the square root of x. F of x is equal to the square root of x. Now for this one here, it can't be everything, because what can a square root not be? A square root cannot be negative. We cannot have a negative square root. So for this one here, we take what's inside the radical and we set it greater than or equal to 0. Greater than or equal to 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. But we can't have the square root of negative 2. So therefore, it's from 0 all the way to infinity. So if we want to write this, this is the inequality. If we want to write it using interval notation, this is going to be 0 to infinity, including 0, bracket, and parenthesis. So if we have a radical square root, we take whatever's inside of the square root. Suppose we have 2x plus 3, okay? We take whatever's inside the square root. In this case, it's 2x plus 3, and we do this right here. We make it greater than or equal to 0, then we solve. So for here, we've got what? 2x is greater than or equal to negative 3. X is greater than or equal to negative 3 halves. This would be our inequality. Our interval notation would start out with negative 3 halves, and it would go to infinity. Again, it would be greater than or equal to that, so that would be a bracket. Then we would have our parentheses. So if we have a radical, we take whatever's under the radical, set it greater than or equal to 0, solve, and that's what we would have for our domain. Again, most of them have no domain restriction. The only reason this one has a domain restriction is because of what it is, which is a square root. That's one of the two with restrictions. Another one with a restriction would be in a fraction. F of x would be equal to 3 over x plus 2. Why would a fraction have a restriction? Well, a fraction has a restriction because you are limited to what you can put in the denominator. You cannot have 0 in the denominator of a fraction. So for a fraction problem, we take what's in the denominator and we say it cannot be equal to 0, and then we solve. In this case, we would have x cannot be equal to negative 2. Bring the 2 to the other side. This is my restriction. However, when writing it using interval notation, it's every number except for negative 2. So it would start out with negative infinity. It would go all the way to negative 2. It cannot be negative 2, so we would have a parentheses, meaning not including. Parentheses on the side of negative infinity. And then we would start out with negative 2, and we would go all the way to infinity. Now, how do we jump over from negative 2 to negative 2? We'll put a union. That means it's everything jumping over the number negative 2 and go into infinity. So that's the restrictions. Either no restriction, or restriction of a radical, or restriction of a fraction. Now we're going to evaluate. We're going to evaluate the functions. Okay, in the next example, we're going to evaluate. they're giving us a function, f of x is equal to 3x squared. F of x is equal to 3x squared plus x minus 4. And they want us to evaluate, mean find the value when x equals negative 3. In order to do this, we write it as f of negative 3. That means we're evaluating where this function is when x is negative 3. It may be doing something like this, okay? And at negative 3, we're evaluating where the function is. We're going to take the negative 3, we're going to plug it into the x, which means we're going to plug it into the x's of the function. And when we evaluate, that's going to tell us where we would be at if x was negative 3. So this is going to be 3 times negative 3 squared plus negative 3 minus 4. Negative 3 squared now is 9. 9 times 3 is 27. Minus 3 minus 4, which is minus 7. So f of negative 3 is equal to 20. F of negative 3 would be equal to 20. So at negative 3, the function would be at 20. That's what we're doing when we are assessing where we're at. Suppose I'm trying to find f of k. F of k. That means, just like over here, we plug the negative 3 in for x's. Here we're going to plug a k in for x's. So we take the same function. It's going to be 3 times k squared plus k minus 4. K squared is k squared, so that's 3k squared plus k minus 4. So in this case, we just plug the k in, and that is the answer. We don't really do anything with it. But we could have find f of k plus 1. F of k plus 1. Again, we plug, in this case, k plus 1 in for the x's. So that would be 3 times k plus 1 squared plus k plus 1 minus 4. Well, you can please excuse your dear Aunt Sally, but you have to do what? You have to do what's squared first. K plus 1 squared means k plus 1 times k plus 1. And when we're multiplying binomials, we have to FOIL it, or double distribute, if you will. FOIL it, first times first gives me k squared. Outside times outside gives me plus k. Inside times inside gives me plus k. And last times last gives me plus 1. If I put this together, this is k squared plus 2k plus 1. So this is what we're going to write in for k plus 1 squared. That'll give me 3 times k squared plus 2k plus 1 plus k plus 1 minus 4. Now I'm going to distribute. This gives me 3k squared plus 6k plus 3 plus k minus 3, because 1 minus 4 is negative 3. Now I'm going to collect my like terms, giving me 3k squared plus 7k, well, negative 3 and a positive 3 cancel out. So this is f of k plus 1 is 3k squared plus 7k. That is all the examples that we have for section 2.1. Again, this was functions and function notation. I will see you at the next one.